To conclude our survey of packet analysis tools, I also want to take a quick look at scanning tools. Now, scanning tools, or network scanners, are basically what security professionals and unfortunately hackers use to map networks out and to find vulnerabilities in those networks. A scanner basically is used on a network to search the entire network to perform a series of scans using either ping scans or some other method of scanning, and basically it's to find living hosts that are out there on the network, to find IP addresses of machines that are up and running. Now, when you do this, you can also find out, in addition to which hosts are live, which ports they have open, and you can perform OS fingerprinting. In other words, a network scan will tell you what particular OS a box is running. Now, it can find vulnerabilities in that if you know a particular host is out there and you know that it's say a Windows host, and you know that because the ports are open, if it's running say port 80, then that might tell you that it's running Internet Information Services, and then you could look up all the vulnerabilities associated with IIS and take your hacking further, I suppose. So scanning tools are basically the first step in a hacker's attempt to infiltrate your network, but they're also very useful security tools because they can tell you what information is out there for a hacker to see so that you can go and fix that. Now, the most popular scanner is Nmap, and we're going to do an example of Nmap here in a moment. Now, the reason I bring up scanning tools in a packet analysis course is that when you're looking at Wireshark captures and so forth, you may want to know what a scan looks like. You may want to have an idea of what a scan actually looks like so you can detect it so that you know when you're being scanned, and you can start closing ports off. You can start securing your firewalls, your routers, and hosts a little bit better to prevent scans from returning that information. So that's the first step. So let's go ahead and run an Nmap scan, and then we'll see what it looks like in a Wireshark capture. Okay, we're in our Windows XP machine, and I've started Wireshark. So I'm going to run a capture. I'm going to start the capture on the 30.10 interface, and then what I want to do is switch over to our other virtual machine. And what we're going to do is, once we're in the virtual machine, I'm going to go ahead and run a Nmap scan. And we're going to use a SYN scan. It's not very stealthy, but it will get the job done. Just to demonstrate how it works, we need to know our target's IP address, and we're going to ask it to do OS fingerprinting as well. So that's a very simple Nmap scan, and we're going to run that scan on our box and see what we get. In the meantime, our Windows XP box is capturing this using Wireshark. So after this is completed, we'll be able to go back and kind of see what the capture looked like, to see what Wireshark picked up, and then we can look at how a scan worked as far as our packets. So we've got a scan that's finished, of course, and it shows several ports that are open. Ports 135 TCP, 139 TCP, 445, shows our MAC address, and it took a guess that it was running Windows XP, which we know to be correct. So let's go ahead and switch gears back again now, and we're going to look at our Wireshark capture, and let's see what we get. Let's go ahead and stop the capture. Now, if we go all the way back up to here, let's kind of look and see what we got. We've got some ARP stuff, which is not really significant in itself, but then let's go and look at where we start getting from the .20, from the backtrack machine to the .10. What we're seeing here, and how you can tell this is scans, is look at the different traffic that's coming across. Let's move our cursor over here so we can just kind of see what's coming. We can get different protocols that are coming in, LDAP-S, FTP, SMTP, and we see that it's being directed towards strange ports, toward ports that we would not usually see. We're also seeing reset and ACK. We see SYNs, and then we're responding back. Our machine is responding back with a reset and ACK, so that it's telling the scanning machine that port's not open. Sorry, have a nice day. So all this information that was collected on the transmitting machine, on the backtrack machine, to tell it what ports are open and which are closed. So good idea when you're looking at the scan itself, when you're looking at the capture rather, is to just, if you see from one IP address over and over and over, different ports, different protocols, and basically SYN scans. A lot of SYNs here that we see, but we don't get the standard three-way handshake back. We see the SYN, but we don't see the SYN ACK back because that port is closed or not working. So we're seeing all this traffic. We can tell it's a scan, it's a SYN scan, because that's all we're getting, and we're getting that from the .20. Now, if we were getting another kind of scan, such as a ping scan, we'd be seeing ICMP requests. We also might see a bunch of ACKs, an ACK scan, and that would attempt to fool this machine being scanned into thinking that it's already part of a three-way conversation. So these are some of the scans we'll see. And we'll talk a little bit more about scanning when we talk about how malicious packets and denial of service things are done in a later session here during the course. This just gives you an idea of how scanning tools work and what you would look for in a packet capture itself.